triangles. We're going to talk about naming them today, characteristics of triangles that help us solve equations, and then the rest of the chapter we're going to be working on determining and proving if triangles are congruent, like if two triangles are congruent. So let's start quickly just by reviewing. I'm sure you know this already, but classifying triangles by, or naming them by their sides and then by their angles. So if I'm naming a triangle, so every triangle has two names, right? It's got a name that you can call it by its sides and has a name that you can call it by its angles, just like your first name and your last name. If we're naming them by sides, it goes by how many sides are congruent. So if all the sides are congruent, we say equilateral, right? Because equa is the base for equal, and lateral, like your lats, or the side of your muscle side here. And lateral in Latin means side, so equilateral means equal side. Isosceles means two sides are equal, and scalene means no sides are equal to each other. We've got equilateral, isosceles, scalene. All right. We okay with those? That should be a review, right? We knew these. Good. All right. Then we have by angles. Every triangle in the whole world has two acute angles in it. Always. Every triangle. Okay? So you have to find two acute angles and ignore them, and then name the triangle by its third angle. So when you see any triangle, first of all, take the two acutes that you know are there and ignore them. And so like this one, if we ignore these two acutes, this one, the third one, is acute. So that's what we name the triangle. We name it an acute triangle. Okay? Throw out the two acutes, this becomes an obtuse triangle. Throw out the acutes, this is a right triangle. Okay? Okay? So an acute triangle has three acute angles, an obtuse, two acute, one obtuse, and a right triangle has two acute, one right. Okay? And one particular kind of acute triangle is an equiangular. Think back to equilateral. Equiangular means all equal angles. And actually, all equiangular triangles are also equilateral. All equilateral triangles are equiangular. So if it has all equal angles, it has all equal sides. If it has all equal sides, it has all equal angles. Okay? So that's just one special kind of acute triangle. Okay? So let's get out your cards. I know for sure there are a couple missing because some of them have disappeared. So if you don't have one, you can just make hand signals or hold up a sign, whatever you want. And now, this would be one of those pages that we probably won't spend a lot of time on. Can you tell me what x would equal? 45? No, not necessarily. Right? Doesn't it kind of mean that this one's bigger than this one? But he's on the right track, because what do you know is already gone? 90. So the two together have to equal 90. But we don't know that if they're equal. I mean, we can kind of look and see maybe they're not, but we don't know they're equal, so how would I figure out what x is? Yeah, you'd set these two equal to 90. So you'd have 2x plus 3x equals 90. And then combine like terms, divide. So 5x equals 90, and 9x is, what, 18? Okay. All right, now let's talk about the characteristics of triangles. And a little bit of vocabulary, anytime an angle or any shape is outside the triangle, we're going to call that exterior. It's going to have exterior in front of it. So like this angle here would be an exterior angle. Okay? This has the word exterior in front of it. Same thing on the inside of the triangle would have the name interior. Okay? It's not rocket science. I just wanted to do that really quick. Okay? All right. And we're going to use that vocabulary to add some new theorems and corollaries. Corollaries are like, you know, like when you buy something or when they advertise something on TV, like, buy these Ginsu knives, but wait, there's more. And they give you like 5 extra gifts. Corollaries are like those extra gifts you get from the original theorem. Okay, they're like add-ons that come out of that theorem as well. So let's talk about these theorems and corollaries. The first one, the triangle sum theorem, you already told me. The triangle sum theorem just says that the 3 angles inside a triangle equal 180 if you add them up. That's all it says. Triangle sum theorem just says the sum of all the angles inside a triangle equal 180. Okay, like I said, you kind of already know that one. The first corollary to that is kind of what we just did. It says if we have a right triangle, okay, altogether the angles equal how much? 180. If it's a right triangle, how much of it's already gone or used up? 90. So that means there's 90 left to split between these 2 angles, right? And if there's 2 angles together equal 90 degrees, what do we call that? We have a name for it. 2 angles, we add them up, you get 90 degrees. Complementary, right? So the first corollary says that the 2 acute angles of a right triangle are complementary. They will always equal 90 degrees. Okay? And again, just it's based on the fact that all told, all the angles equal 180. That's kind of the original theory behind it. Questions? We good? Okay. And the measure of each angle of an equilateral triangle is 60 degrees. Again, we kind of already did this, but if it's equilateral, it's also what? Right? If it's an equilateral, it's also equiangular. So if the sides are equal, so are the angles. So in an equilateral triangle, all the angles also are congruent. So if I've got 180 altogether, how would I figure out what each angle is? Yeah, exactly. Divide by 3 because we're splitting that 180 into 3 equal pieces. So to find the measures of the equilateral triangle, you just take 180 and divide it by 3. So each angle is 60 degrees. Okay. So far, nothing earth-shattering, right? Too taxing. Anything need to be cleared up? Okay. Then the next theorem is the exterior angle theorem, which kind of sounds like gobbledygook for a second, but I'll explain it. We'll show a picture and it makes it clearer. It says the measure of an exterior angle of a triangle is equal to the sum of the measures of its remote interior angles. Okay, which makes sense if you think about it. Do you want to take a second to copy that down before I move it? The measure of an exterior angle of a triangle is equal to the sum of the measures of its remote interior angles. called the exterior angle theorem. And remember, exterior means it's going to be on the outside of the triangle. And you form exterior angles just by extending one of the sides. So if I extended this side out, the exterior angle would be here. Or if I extended that side, the exterior angle would be there. It's just formed by extending one of the sides of the triangle. All right, so it says that the exterior angle of a triangle, so this one or that one, doesn't matter, but let's take this one, is equal to the sum of the two remote interior angles. So let's pull that apart. Interior means inside the triangle. Just think about what remote means in English. Remote means like far, right? Not next to. Like your TV remote means you can take it away from your television, go sit on the couch and change the channel. So remote means not next to it. So the two interior remote would be here and here, for this angle, right? Now, if it were this angle over here, it would be these two. Does that make sense? Okay, just remote interior. So why that is, if you think about it, let's give these angles names. Like let's call this A and B and C and D. Okay? We know that all three angles together equal what? 180. So the measure of angle B plus C plus D equals 180. Okay? We also know what kind of angles are these two right here. They're a linear pair, so what do they equal? 180 as well. So angle B plus angle A also equals 180. Okay? Now, if you think about it from a proof point of view, if they're both equal to 180, aren't they equal to each other? Right? So I can kind of take this out of here and make them equal to each other. And there's an angle B on both sides. So I can pull this out. I could subtract out an angle B because it shows up on both. Okay? So that, you know, you can always turn on TV because I feel like my back's to you all the time. So do you want to turn on the TV so you can see what's going on in the board? So this tells me that angle A is equal to C plus D. And think about it intrinsically, it doesn't make sense if these two together equal 180 and these three together equal 180. That B is the common point. So if I need to find the measure that, if I need to find the 180 degrees without that part, it's the same as finding 180 degrees in the big triangle without that part. So wouldn't they be the same amount? Right? So that's what the exterior angle theorem says. This angle is equal to the sum of those two angles. Yes? A. What would be, if I call this, let's say E, what would be the remote of E? Michelle, what would be the remote? What two angles would be remote for angle E? Not D, B and C, right? Because remote means not right next to. Okay? So yeah, it would be B and C. Would be remote to E. Okay? Does that make sense? Everybody? Make sense? Okay. All right. And last but not least, the third angle theorem says that if two angles, and this is one that compares two triangles together. Okay, it's our first one that compares two triangles, but after tomorrow, we're going to be comparing two triangles the rest of the chapter. So, and the third angle theorem says if two of the angles in each triangle are already congruent, so if that one's congruent to that one and this one's congruent to this one, then the third angles are also congruent. And we'll use this a ton in proofs. But it does not make sense. Like if this is 60 and this is 80, that's 140, so this would be 40, right? And if these are equal, then this also has to be 60 and 80, so that's 140, so that makes that 40 as well. Okay? So that's all it says, is that if two sets of angles are already equal, the third one is also equal. Okay? All right. Now, let's solve some problems. All right, so given that angle J is congruent to angle M and K is congruent to angle L, okay, we have to figure out which of our theorems we can use to solve this equation. So can you see the two triangles? Like the first triangle is NJL here, and the second one is PKM. Okay, you see those two triangles? They're kind of overlapping, but you can see them. All right, so which of my theorems that I just learned would help me figure out what y is equal to? Yeah, the third angle theorem, because I know that these two angles are equal, these two angles are equal, so the third angle must be equal too. So I know that 3y squared is equal to 12y squared minus 144. Now, I notice right away that there's squares here, so I'm thinking this is a quadratic. Normally, in a quadratic, you would want to set it equal to 0 and factor, okay? But I think I'm going to get off easy today because there's no y term. There's only squared terms. And whenever there's only squared terms, usually I can just solve by using a square root. I don't have to factor. Yes, ma'am. So I'm gonna work with this and just try to solve it without having to factor. So the first thing I'm going to do is get all the y's together on one side and the x's together on the other, or the constants together on the other. So I'm going to subtract 3y from both sides, or 3y squared from both sides. And those are going to cancel and become 0. This is going to be 9y squared minus 144. Okay, and I'm going to get the constants on the other side. If you were familiar with the difference of perfect squares, you could factor at this point, but if not, this is what I would do. All right, so that's going to cancel those. This is going to become 144 equals 9y squared. Okay, but to solve an equation with a square without factoring, you need the y squared to be by itself. So how am I going to get rid of the 9? Divide, yeah. Okay, so that's going to leave y squared on this side, and 144 divided by 9 is 16. Okay, now how can I solve for y squared? Exactly, square root. Okay, square root of y squared is y. Square root of 16 is plus or minus 4. Remember, because you can have negative 4 times negative 4 or positive 4 times positive 4. And so to find angle N or angle P, I'm just going to take my 4s and plug them in there. Does it matter if I plug in a positive or negative 4? No, because I'm squaring it. So either one's going to give me the same answer. So I'm going to plug in my 4 and square it. 16, or 4 squared is 16 times 3 is 48. So I get 48 here and there. Okay, And if I wanted to check that, I could plug 4 in there and make sure it was right. Alright, I just want to show you that one because maybe it's been a while since you had quadratics. Why don't you try this one on your own though, because it's just